now let's get started. So I thank everyone to join this webinar, and we'll have a monthly webinar to help more engineers to learn data streaming. And my name is Jove. And all the friends in India, and we also live streaming this to LinkedIn and YouTube. And it's 9:30 p.m. in PST and midnight in EST. But no worry, this webinar is also recorded, and the slide deck will be shared to you. And today we'll be talking about how to run SQL on Kafka with different tools, and the best tools is Timeplus, and you will know why. And if you are not familiar with Kafka and even don't know SQL, no worries, we will also explain the basics. So some housekeeping thing that is, no matter whether you are on Riverside or LinkedIn or YouTube, you can submit questions on your platform, and our team member will monitor them, and we'll cover the questions at the end of the webinar, and feel free to send a message to share where you're coming from, the country name, the city, or even a brief self-introduction. And you can also join our community Slack to follow up with us and chat with other Timeplus users or fan of data streaming. And also to appreciate you joining the live webinar, and at the end of this webinar, we're going to have a lucky draw to send you an Apple Watch. And you can follow me on LinkedIn and Twitter. A little more about myself. So my name is Jove. I live in Vancouver, Canada, and I like all kind of ball game like snowboard, surf, skateboard. And I'll also run a podcast regarding how to learn streaming SQL in 3 minutes. Each video is very short. You can learn the basics. But now you already joined this webinar, so we can explore the basic concept together. And I don't have to read the webinar line about this agenda. And if you are watching this webinar from a laptop or from a PC, it'll be great if you can follow our guide to quickly set up Timeplus and query Kafka using SQL. And please feel free to prepare any questions, and we will do the Q&A and do the lucky draw in the end. So part of the reason why I didn't join the Kafka Summit in Bangalore in India this month is that I'm preparing the speak session at Startree's Real-Time Analytics Summit last week. Me and Gang, our CTO, did a speaker talk. And let me use one of the slides from the keynote. That is real-time analytics is everywhere. No matter you are using Uber or some car sharing, whether you are monitoring any stock price or doing any kind of IoT monitoring, all those are live data, and you need to get the real value from those data, and you only have a limited time to take actions. Here's a few use cases, and those use cases are actually already implemented using Timeplus. For example, on the data engineering side, you can use Timeplus to move data from one Kafka cluster to the other Kafka cluster, or move from the OLTP such as the MySQL to OLAP database such as ClickHouse. Of course, you can do all kind of live and real-time data cleanup, masking, build a live dashboard. In the fintech area, you can get the live market data. You can come up with a live pricing model and generate the signal for you to buy or sell. And of course, in the case of network security, imagine if you can get the live log from the web access log, from all different firewall log, then you can have a better chance to understand the network traffic and figure out whether someone is doing DDoS attack. On the IoT, there's so many different EV and different sensors at home, at the factory. Then using the real-time analytics can help you to better understand how the device is functioning, whether they are overheat, whether you need to take some actions. Of course, in the case of customer care, and you can have better understanding about how your customers and potential users are using your products, what kind of a message they are talking about in the social media, and you can build a better customer loyalty and have a better customer satisfaction. And we cannot avoid AI and machine learning. So today, there are so many progress on the AI side. And in the end, the AI really need a very high quality data, and the AI can access the latest data, then come up with a better suggestion, make the conversation more meaningful. So all in all, that is the live data is everywhere, no matter at the edge or in the cloud. So there are so many data, and this number 46 ZB is one expectation, one prediction, and many of them, about 1/3, is generated at the real time. But unfortunately, or luckily, if you think in the other way, that is, today there's only 1% of the data, those live data, is analyzed. So if you can obtain the knowledge and the skill, the best practice, how to process data in the live time, in the real time, you can have a better chance to get the value from the live data. And today there are so many different tools for you to easily consolidate data in a central data platform such as Kafka or Pulsar and many other tools. Then you don't have to connect the dots every one by one, and all you need is to figure out what's the best way to consume data from Kafka. And we believe at the Timeplus, SQL is the best tool, and we are providing the best tool in the market. As I mentioned, that is, you don't have to be familiar with Kafka, and so I will spend maybe 3 minutes to give you a quick introduction about Apache Kafka and the Kafka API, because there's more than Apache Kafka, there's other vendors. And hopefully, if you are not familiar with Kafka, this can be your takeaway. By attending this webinar, you will know the basic concept of Kafka and why it is popular. So, so at the very beginning, the basic thing that is Kafka is have this key and a value. The key and the value can be anything. It is very common to have a text, but you can also put a binary in the value, such as you can put an image. For example, if you can have an IoT sensor, you might take a photo every X second, and you can put that image in the binary as a value. But what is more powerful, that is, as a client, you can push the data to the Kafka, no matter it's a single node or a cluster, and this is going to be, they call broker. And the broker can talk to each other, and you only need the first broker, which is the Bootstrap server, to send the data, and that Bootstrap server will help you to distribute the data to other servers. And the Kafka is really great in terms of distributed setup. And there's a basic concept about the producer, which is send the data to Kafka, and the consumer simply to get the data from the Kafka. And Kafka organized the data logically using the topic. So you can have A, B, C, 3 different topic. And the topic, actually, the data can be put in different servers. Because Kafka has been there for about 10 years, even before the popular cloud services like S3. So you can set up a Kafka by yourself using multiple servers, and any server can go wrong. But with the nice design of Apache Kafka, you can you set a replica, and so the data will be put in different. You can put different servers, and if one server goes down, you can easily recover them. And some other topic, some other key concept, that is each topic can have multiple partitions, and the purpose of partition is help you to maximize your read and or write throughput. So if you are on a high-end disk, you might be able to create a multiple partition, and each partition essentially can take care of some of the read and write. And the more partition you have, you can have more concurrent read. And all the consumer can put into a consumer group so that they don't overlap. One data is only consumed by one consumer. So that's the basis of Kafka, and feel free to search online to learn more. So so let me talk about why we build the Timeplus. Again, there can be a lot of architecture design, but I will start with this 3 common tools or the concept. Like Snowflake is a very popular data warehouse, no matter in the cloud, or you might also have some similar thing on-prem. And the Kafka, as I mentioned earlier, is very popular as a distributed message bus. Flink is popular regarding the compute. However, Snowflake or other data warehouse or the OLAP are not designed for streaming. So you might have to put that data there and get the data 2 or 5 minutes later. It's not real-time enough. And Kafka is streaming for sure, but it's more focusing on the storage side. And it's not for computing. It is not easy for you to run the compute, figure out what's going on in Kafka without writing code. That's the reason why we believe Timeplus provides a very good SQL-based engine for you to get things done. And Flink is kind of popular for streaming processing, but it's not a database. You have to set up many other things. I will talk about this later. But because of those reasons, we think Timeplus can play an important role to put into to cover the storage, the query processing, and the transformation. And our method is to provide a stack for you to easily process data, no matter it's in Kafka or in other message bus or platform. It's very easy to use because we think the more people can understand the basic, they can get hands dirty, more people can easily explore, unlock the value from the data. And we choose SQL as the most suitable tool for people to easily get started. And we also focus a lot on this unified streaming and historical analysis in a single platform. So you don't have to set up multiple components, and you have one single engine to ask both what is going on and what is coming and what's in the past. And we're really focusing a lot on the performance and the lightweight. So as you can see, as our demo later, you can easily get everything done by downloading a single binary. And it is at a high performance. You don't have to worry about the JVM and other things. So before I run the demo, I want to also give you a brief introduction about the Timeplus Enterprise, which is available both on the cloud or as a self-hosted solution. And we can connect to many upstream and send the data to the downstream. But you don't have to try our cloud version. Actually, you can go to GitHub, So this is our core engine to give you all the nice features, and you can try anytime. You can connect with your Kafka or other servers, and you can explore the powerful SQL engine. So I don't have to go into the details, but you can see that we can support both the injection and the query through our TCP or HTTP endpoint. And we provide some features inside, but all those features is delivered as a single binary. And we can provide both the streaming storage, we can provide the historical storage, the streaming query and historical query, and using materials view as a background job. And we can send data out to Kafka, to file system, to ClickHouse. So you will get a better understanding when I demo it. But again, it is not the only tool for sure. And actually, Gang and I did some talk in some other open source conference. There are many tools in different language with different focus. But in this webinar, I'm going to talk about, for example, why ksqlDB or Flink may not be the best option for you. So let's talk about ksqlDB first. ksqlDB is, as the name shares, that is, it tried to convert Kafka as a database. But however, it is quite limited, and it have deeper coupling with Kafka. So not only it only works with Kafka, it doesn't work with other message bus such as NAT or Pulsar or AWS Kinesis. But even for Kafka itself, it is tightly coupled with the current Kafka cluster. So if you have multiple Kafka clusters, so you cannot use ksqlDB to cross query them together. You have to run ksqlDB in each of the cluster. And also, because they try to use the Kafka as the engine for this ksqlDB, so there will be a lot of new topic created on your Kafka. So for example, if you already have 100 topic on your Kafka, by using ksqlDB, you might end up with maybe 120, 140, a lot of more other topic will be added. And this can degrade the performance and the throughput of your Kafka. But Timeplus on the other side, it's very efficient. It is written in C++, and it is very flexible. We support Kafka, but also we support many other systems, and there's no hard dependency. And we can easily, for example, run a SQL to join data from two Kafka cluster. So, and the other thing that is in terms of the capability of analytics or the SQL part, ksqlDB has a lot of limitation. For example, they don't support CT, which is a common table expression, or even subquery. So you might have to write everything in a very straightforward way without using CT or subquery. The join is very limited. Either there's no self-join, and the join require co-partition, which means that is you have to be very sure how your joining workload will be when you design your partition. And there's a limited number of SQL functions, and there's no index. However, for Timeplus, we support thousands of SQL functions. The powerful and the flexible joining can make you very easy to run your query in whatever way. You don't have to keep changing your Kafka setup. And we provide upsert and delete, not just append only. And we have quite a lot of rich and sophisticated database index to make your query faster. So those are the major two reasons. And if you know about Apache Flink, this is the other common tools. However, they also have some downside. For example, the Flink SQL is primarily focusing on the streaming ETL, or with some complex event processing, which is a CEP. However, Timeplus can do more than that. We can also be the serving layer. We can give you live alerts or dashboards. And the deployment is also a big thing. Flink is not lightweight at all. You have to set up JVM. You have to allocate a lot of CPU and memory. And there's many other components in Flink. However, in Timeplus, it's a single binary. And even you run a cluster, it's just the same binary and with a conversion file. It's very lightweight and the best leverage the modern CPU architecture and the Linux new features. The capability is Flink may support hundreds of CQs, but we support thousands of. And we can leverage the vector or SMD, and we don't to get the best performance. And unlike Flink, we don't really need RocksDB, which can be a challenge for many large-scale deployments. On the storage side, if using Flink, you might have to send the data to S3 or send to the other OLAP database, because the Flink itself only keep the state, not the data itself. The case of Timeplus, we have both the streaming storage and historical storage. So it is all-in-one, battery included. So it is very easy for you to query all the live data and historical data in Timeplus without set up the other data warehouse or OLAP. And also the last one, it is very important, that is how easy it is to learn. And the Flink, to use Flink SQL, you might have to set up the Flink cluster, and there's a many lengthy setup step, and you have to tune many parameters. But in Timeplus, we really focus a lot on the easy to learn, and there's only one binary, and the SQL is the first citizen to set up everything. So so the next section is really about how to show you to install Timeplus Proton and run some demo. Again, if you have laptop or PC around you, it will be great if you can follow the guide. Otherwise, you can just watch my demo, and feel free to do this exercise by yourself to have a try about Timeplus. So let me share this screen. So this is our documentation, right? So it is very easy to install. So if just run this command, it will download the binary. And of course, if you are on Mac, prefer Homebrew, we also have Homebrew as option. You can also run Docker. For example, if you are on Windows, this Docker image can help you to set up things. And because today's demo, we are going to load data from Kafka. So we are going to use a Docker Compose stack with the Kafka compatible tool, which is Rapanda, to set up all the data. So to demo, let me show you. Okay, so I'm sharing my command line, right? So it is empty, right? And as I mentioned, that is if you want to download our Proton, that the best option probably is to download our single binary. So just run this CURL, and it will download the Proton binary, and you can just run it immediately, even without install it. So today it's so it is already installed, and this is the file, and you just run Proton local, and Proton this SQL engine will be ready for you to run. And if you have Kafka on your laptop or in your data center, you can connect to it. So so Proton is so for example, you can select one or select now. So this is a SQL interface, right? But I'm not going to use this directly because I'd like to set up a Kafka and to show you how to export data in Kafka, right? So what you can do is you can go to our GitHub repository in the Proton, in the example folder. There's a e-commerce folder, and there's a doc compose file, and you can download this file, and you can simply run doc compose up. So doc compose is a very nice tool for you to have a single command to bring up the entire stack. And in this stack, you can see we have Proton inside, but also so let me show this Docker PS. So we have the Proton here, and we have Rapanda, which is Kafka compatible server. The UI is Rapanda console, and we have the data generator, which is OR shop. And let me show you the Rapanda console, which is the nice UI. Okay, I'm on this localhost 8080. This is the Rapanda console. As you can see, those are the topic. As I mentioned, that the topic is the main way to organize data. And if you go to the front end event, so this simulates the click stream scenario. If you keep a refresh it, you can see the data always come, right? And all the data is in JSON format. So give you the idea about which URL is being visited, from which IP address, all the HTTP headers or response. So this is a very typical live data, right? So imagine your task is to understand how many requests for which website or which page, whether there's any errors, for example, 404 errors or 500 errors. So you can come up with the live alerts by using this live data. So go back to the console. Okay, so go back to the console, and what I need to do is I can run Docker execute exec to this Proton image or Proton container, and I'm already in this. And again, this is the same client. And what I need to do is I needed to connect to the Kafka, right? So what I need to do is I can create an XNO string. So the XNO stream is the primary way for us to connect to other systems. We start from Kafka, but also we can support other systems. And the Repanda, this 80, 89, 82 is the broker address, because they are in the same Docker compose. So it's very easy for you to connect to it without worry about what's the actual IP address. And the topic is the front-end event. So once you run this command, then you can easily export data from it. Say I select star from, for example, the name I choose is from, and even I can use tab to do the autocomplete. And after I press the enter, this query starts running. And because it's a streaming query, not like other traditional query, it's keep running and give you the latest results. Right? You can run Command C to pause it. And for example, if you want to see what's the, for example, one of the attributes, we also support very flexible JSON parsing. So all the data is put into a single column called raw. Right? For example, if I want to see what is the request URL, I can just using this expression to jump to that JSON path. If I run again, so this is the you exploring all the new events and get the URL. And you can also do many other things, such as you can run a count. And every 2 seconds will give you the result, like since I run this command, how many new events. So as you can see, using SQL is really powerful for you to almost ask any question to your Kafka without writing any code. Before this tool, you might have to use Kafka Java API or Python API to write some code and compile it. But the SQL is such a nice tool for you to compile your question as a SQL, and you can just run them. And in the Timeplus Enterprise, you can even turn this into a nice chart. So and you can also do other things. For example, like you can filter data. Say all the events, I don't care about HTTP GET. I only care about the post. You can do a filter like this, just using a very straightforward while clause. So all the events from the post is available for you. Then you are asked how I can send the data to other systems, right? So you can create the other external stream as your target, and you can, for example, like this, you can create a new external stream, send the data to a new topic, such as this masked FE event, and you can later on you can create a materials view, which is a data pipeline for you to convert data from the query and send to the other one. So this is very easy to use, and I don't have to run the demo in this terminal. So let me switch to the last part of the demo, which is the UI part. So so this is the Timeplus Cloud demo server. You can go to demo Timeplus Cloud and just log in using your Google or Microsoft. And the SP demo, which is a stream processing demo, and I'm showing you that is similar thing as I do on the command line, but in the Timeplus Enterprise, you can create a visual representation of it. So this is the Kafka topic coming from our server, and you can read it, and you can even do some joins and downsampling, right? So this is a more complex query. Essentially, it just query every 5 seconds using a tuple window and group by the HTTP code. Then you can join this data together with a dimension table. You see, this is dim code to status. This is a table in ClickHouse, the other database. So I can show you that is you can join data in your Kafka together with data in ClickHouse. And finally, the data is sent to the other table in ClickHouse. So you can easily build your streaming ETL easily using Timeplus. So there's other important topic of stream processing such as watermark or some other event processing, but due to the limit of the time, I don't have time to go over one by one, but feel free to check our website or join our Slack to learn more. And back to the presentation. And now I think it's the right time for you to think of any questions, and let's answer them. And we also do the lucky draw. So let me go back to this page. So now is the Q&A part. I guess we can spend at least 5 minutes on the Q&A, and my colleagues monitor in different channels on the LinkedIn, on the YouTube, on Riverside. So I will check the questions, and feel free to share the question to me. Any questions? My team is comparing the list, so I see a question coming from Ponis, right? Sorry if I pronounce your name wrong. Can you talk about AI-based use cases? Yeah, for sure. So I actually work with Celix, which is a very popular vector database, have a real-time RAG. RAG is a new concept that is you can fetch the latest data coming from different sources, for example, from social network, from weather, and you can generate the data and put this into your AI context. So usually the AI is trained with a lot of data, but the moment you get to the model is already have altered data, right? So using RAG, you have a better chance to combine the powerful model together with the latest data. And so some example that is you can check what is the current flight status, how many people on the waiting list, what's the price, and what's the weather. And if you build everything together, and you can have a better AI robot to encourage people to change flight or order certain things. And this is very real time. Yeah, AI now is really about high quality data and live data. I see the other question is, what's the difference between Proton and the Kafka stream? Yes, it is. Yeah, I'm glad you mentioned Kafka stream. So Kafka stream is part of the Apache Kafka distribution, right? It is more like a library, a Java library. And the ksqlDB is built on top of it. So remember, I didn't list all the key points, but on just these 2 slides give you an impression that is even ksqlDB is quite limited, right? And using Kafka stream will be involve more coding efforts. You have to run the similar things, and you have to compile the package, deploy it, and there's still have limited, for example, join or group by. So ksqlDB just make the syntax a little bit easier, but all the limitation is also available in the Kafka stream. But using Proton, you can just express your joining logic or data processing logic using SQL in a very powerful way. Yeah, so feel free to give Proton a try or try our demo environment in the cloud.
Hi, Joe. Can I
Sure.
add
Go ahead. Yeah.
yeah, just add something to the AI use cases. Actually, there are several cases. So first case is that Timeplus is your data pipeline. You whatever data application you're running, you need AI application. You need to pack different data. You need to do different data. So Timeplus can help to do this kind of data flow. The second one is actually the web vector database help you do all these kind of embedding vector search. Because Timeplus actually also supports vector-based search. And the second one, you can actually store your vector in Timeplus. The third one is actually the monitoring as well. With AI, you need to monitor what's happening with your so Timeplus can help you monitor all these actions, all these monitoring AI. Of course, we are working on some AI-based solutions. If you have any suggestions, questions, comments,
Okay. Yep. And I think, yeah, we feel free to join our Slack to ask more questions. And especially if you try Proton or Timeplus Cloud, if you give some feedback, that'll be great. So now let's the last part is the lucky draw part. So thank you everyone to join this webinar from different channels. And I'll, for the sake of hack and I will using a SQL to generate a random number, and but I cannot share all the attendee list with the email. I guess it might be some privacy issues, but I will generate. My team will come up with the full list, and I will generate a random number. 1 second, please. On Riverside? Okay, sure. Yeah. Okay, yeah. So yeah, maybe one more question. So this is from Rima, right? So thanks for the talk. Can you talk a little bit about schema handling on the hand Timeplus ensure order? So yeah, so it is very common for you to put Kafka. I guess maybe 20% of the people use a schema, right? Even schema might be give you a better data quality, but it's very common for you to put a text or JSON. But when you decided to use a schema, for example, no matter it's protobuf or Avro, and you can encode by itself, or you can put the schema in a schema registry. So all those features is nicely supported in Timeplus, and especially when you have a message, and the message itself can indicate what is the schema, and we can just read it. For the case of order, because the Timeplus is designed for stream processing from the day one, we implement our own format we call Timeplus data format, which is TDF. So in the TDF, we have those timestamp, we have this log sequence number. So no matter data is in our streaming storage or historic storage, we can make sure there's no data duplication. And even when you run a query and in the middle of the query, maybe there's something wrong. For example, the server is being upgraded. And then we can, when the server is up, we can resume that process to read from sequence number. So we do take care of those order very seriously. And in more complex cases, maybe there might be out of order or late event. For example, in the IoT cases, you never know whether your device is running into some network issues. But we leverage some industrial common practice such as watermark to set a certain policy whether you can wait for a certain late event or if the event is too late, for example, it's already 2 hours late, you don't have to keep waiting it, so that we can balance the performance and accuracy, and you don't have to run into a very big state. Yeah, so we're happy to contact you to learn more detail about that. Okay, so lucky Joe time. So let me do the final check with my team. Again, this is a very interesting. This is a live event, so anything can go a little bit risky. So what I will do is I will go to my SQL console. All right, so so I will press the first few buttons, but this is just to demonstrate that is what I do is I use a random function. I generate a number in this uint 32, and I mod by 100. And the first 2 click is just for demo purpose, right? So you can see this is a different number over time. And I will run this final time and pick up a number and check our list. And if the person is still in our webinar, then we will announce the winner. Okay, the winner goes to 64. Okay, I think the lucky person is Mahal, M-A-H-U-L, and the last name is M-A-Y-A-N-K from Accenture. Thank you for joining this, and I'm not sure whether you are in the webinar. And if so, please share your company address, and we'll contact you, and we'll ship a new Apple Watch to you. And this is just a token to show our appreciation. And we hope that is everyone who even don't get the lucky winner, but you still learn something from this event. And again, our session is recorded, and we will contact you using email to share you the slide deck. And feel free to join our community. And if you can check our repository at GitHub, that'd be great. If you can give us a star, that'll be even better. And we are looking forward to hear from you again. And we probably will have monthly meetup on different topics. Again, thank you everyone to join the session, and see you next time. Goodbye.